today in coordinate geometry we're going to work out how to find the length of a straight line. Now rather than me just giving you the formula, I want to show you where the formula comes from, because hopefully it will help you remember it. So here we have a straight line given and we have two coordinates A and B. A is 1, 1 and B is 5, 4. Now just like when working out the gradient, if you drop a triangle between these two coordinates, it creates a right angle triangle. And we can work out the length here going across and the length here going up using our scale on our graph. And once we have two lengths within a right angle triangle, we can work out the third by using Pythagoras' theorem. So using our scale, the length going across, it's going up in ones. So we've got 1, 2, 3, 4 here. And going up, again the scale is going up in ones, so we've got 1, 2, 3 here for our lengths. So to find the length AB, we want to square the 4 and the 3 and add them together. So our AB squared equals 4 squared add 3 squared, remembering our Pythagoras' theorem from GCSE. If we work out what we've been given now then, so AB squared, 4 squared is 4 times 4, so 16, 3 squared, 3 times 3, so 9. So our AB squared is 16 plus 9, which gives us 25. Now remember, we then want to get rid of the squared, so we need to square root to both sides. So AB is going to be the square root of 25, which gives us 5. So the length of AB, the length between these two coordinates here, is 5 on this graph. So we're going to use this idea in general terms. So in general, we'd have two coordinates, but we wouldn't know their values, so we'd call them x1, y1 and x2, y2. Just like we did, we drop a triangle to create this right angle triangle, and we need to know the lengths of the triangle. So like the gradient, this length going down here was our y2 take away y1. And going across here with our x-axis is x2 minus x1. So to find the length of these coordinates, so to find the length of AB, we'd have AB squared, and remember AB is still the longest side, it's your hypotenuse, so you're going to be adding the other two sides together and squaring them. So AB squared equals your x2 minus x1 all squared. Notice I put brackets around them and then the squared on the outside because it's more than one thing, plus your y2 minus y1 all squared. Now obviously we can't work out these values as we don't have any numbers. So your next step is to get rid of that squared. So we want to square root. So AB is going to be the square root of x2 minus x1 all squared plus your y2 minus y1 all squared. And this is your formula to find the length of the line. It doesn't matter whether you put your y2 minus y1 squared first or your x2 minus x1 squared, because you are adding them together. So it doesn't matter which value or which length you put first. So we're going to have a look at this in action now through some examples. So find the length of the line joining the following 2 points. So remember, we don't sketch the line, we just use that formula. So to find the length of the line, remember your formula is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now to help me with this, like we did with the gradient and the midpoint, I'm going to put x1, y1 on the top of my first coordinate and x2, y2 on the top of my second. And now we can substitute in. So keep the square root there. x2 minus x1, so we've got x2 is 1 minus x1, which is 4, all squared, plus y2 is 0 minus y1, which is 2, all squared. So we have the square root of 1 minus 4, which is minus 3, all squared, plus 0 minus 2, which is minus 2, all squared. remember, you do have a calculator for this, but we like to try and break it down. So minus 3 squared is minus 3 times minus 3, which is 9. And minus 2 squared is minus 2 times minus 2, which is 4. So we've got root 9 plus 4, which gives us 9 plus 4 is 13, so the square root of 13. Now in additional maths, they often like it left in surd form, it's called, so left underneath this root. So the length of the line is root 13. Example 2 then, so we have 6, 3 and 2 minus 1. So again, if we put x1, y1 on the top here and x2, y2 on the top here, and remember the formula to find the length of the line is the square root of your x2 minus x1 all squared plus your y2 minus y1 all squared. If we substitute in then, so your square root, so x2 minus x1, so we have 2 minus 6 all squared plus, and then y2 is minus 1 and y1 is 3, so minus 1 minus 3 all squared. If we break it down underneath that root, so square root 2 minus 6 is minus 4 squared plus minus 1 minus 3 is minus 4 all squared, which gives us root 16 plus 16, which gives us root 32. Now if you put root 32 in your calculator, you will see it will simplify it for you. And additional math does often ask for it in its simplest form. So root 32 simplified down gives us 4 root 2. Last example then, so we've got minus 2, 2 and 3 minus 1. So again, x1, y1 and x2, y2. And we're using the formula for the length of the line, which is the square root of x2 minus x1 all squared, add y2 minus y1 all squared. So substitute the values in. So we have x2 is 3, so we've got 3, take away minus 2 all squared, plus, and then your y2 minus y1, so minus 1 minus 2 all squared. This gives us, so 3 minus minus 2, so minus and minus makes a plus, so we have 5 squared plus, and then minus 1 minus 2 gives you minus 3 squared. So this gives you the square root of 5 squared, which is 25, plus minus 3 squared, minus 3 times minus 3, 9, which gives you root 34. And if we put that into our calculator, root 34 doesn't simplify, so that is your answer.